Hello everyone, this is Allan from Allan Creationz back on your internet screen. So in today's tutorial, I'll be taking you through the Dart programming language, which is actually one of my favorite programming languages. So actually that is a simple programming language that you can easily learn within a week and you're done. So when you talk about Dart, that is a programming language that was developed by Google. So one of the reasons why you would be learning that is used in a framework called Flutter. Flutter is actually an SDK, that's a standard developer kit. So now when you use Flutter, Flutter is actually used to develop applications. You can develop Android applications, iOS, desktop applications, and actually websites using Flutter. So it's way too convenient than writing native code. So that's the reason why you should be learning that. And it's actually one of the simplest programming languages. For those of you who have a little experience, you very much know that is similar to some programming languages like Java and JavaScript. So now, in today's tutorial, I'll be using Visual Studio Code, VS Code by Microsoft, as my default text editor. So now what you have to do is open up a terminal. If you already have Visual Studio Code installed on your system, type in code -N to launch a new window. So when the new window opens up, actually what you can first do is you can create a folder where you'll be saving your projects. Right click, create a new folder. So let me name this folder that tutorial. So right click on the folder, click open with code. It's actually very fine if you're using a different text editor. Yeah. So let's create a new file. I'm going to name the file anything. You can actually give it any name you feel like you want to. Let me name this first .dart. The extension is very important. .dart. So this one will be writing our code in this space you see here. So in that programming language, the first thing we begin, actually when the compiler is running our code, it checks for the main function. So when you write code without the main function, the compiler won't run your code. So what you have to first do is call the main function just by typing the word void, then main, then open brackets. Then actually what you have to do next is type the curly braces. So here in the curly braces, here exactly in the middle, within the curly braces here, is where we shall be writing 90% of our code most of the times. I think the only time you have to write code outside the main function is when you're writing functions and classes. That's where we only write code outside the main function. But most of the times, we write our code within the main function. Now, what this void means, it means that the function returns nothing. You don't have to worry. We shall be talking about functions later in this course. So we're calling the main function void main function. So this main function returns nothing. Now, today's tutorial, I'll be taking you through data types and comments in that, to make it so simple. So now, if you've actually taken tutorials on programming, the very first thing we all do as developers from start, we print a hello world statement. It's not compulsory, but it actually gives you a real life experience. Now, what I have to do with that, I just have the keyword print, open and close brackets. Then within these brackets, where you type what you want to print out, I can say print hello world. Then save your code by clicking Ctrl S. Now let's open up a new terminal window. So when you open up a terminal, this is our terminal right here. Let me first clear the terminal by typing in clear. So I'm clearing a terminal so that you can see what I'm going to run. So now when you're running that files, what you have to first do is tell the terminal I'll be using that. So I already have that installed in my system. So what you have to do is type that. Then with the file name followed by the file name, that is first .dart. So we'll be running that. Now you can see our compiler has compiled our code and given us an output, which is print hello world. Now this is what we printed out. The statement hello world. So now what I have to do next, for example, you would want to write out a program that prints out salutations to people, yeah. So you can see. Now let me modify this to make it more personalized. I can see hello some name. So let me say I can say hello Allan. So when I save and run this should run and say, you see hello Allan. So now when you look at this line of code that we have here, we have this print statement and the open and close brackets. So these brackets actually, within the brackets we type what we want to print out. So what you see here at the end, this thing you see at the end is semicolon. So it tells the compiler this line of code stops here. So these are very important. Now let's go ahead and talk about data types you have in that. So in that we majorly have four data types. So the first one being a string. Yeah, we have strings in that. We also have integers. We have integers in that. We have doubles in that. I will explain them later, you don't have to worry. Then we also have bool, which is a boolean data type. Yeah. Now with strings, these strings are very important. They can be used to store, I would say, various types of data. So you can actually use strings to store names, because people's names, I would say, are strings. You can use strings to store a lot of data. Yeah. I can say strings can be used to store, I would say, statements, stuff like that. Now when you talk about integers in that, I would say these are whole numbers. Basically integers are whole numbers in that. So integers, now you can say they can be negatives or positive as long as they don't have a decimal place with them. So those are to call integers in that. So when you talk about doubles, so in some programming languages, these doubles are called float point variables. Now this double here, it is used to store decimal places, anything to do with the decimal place. So you start using a double. Now when you talk about booleans, they actually store two values. It stores either a true or a false. That's what a boolean does basically. Now let me take you through one by one. Let's begin with strings. So now when you're declaring a string, what you have to do is, I would say, let me type string with a capital S, because that is case sensitive. String. You can say string. Give the string a name. I can give the string Allan. Let me give it a more reasonable name. I can say string salutations. So what are we storing in this string? So when you're storing a string in that, what you have to do is you use so in that, that's it. So we're actually using this, you don't say. So I'll be writing everything to do with the string inside within these two marks. So let's say salutation string, I would say hello. So let's store the hello within there, and we also want to store the name of the person we are greeting. Yeah, I can say string, let's say name of the person we shall be greeting, because open these quotation marks. Then the name, I would say, now this time around we shall be greeting someone else, of course. Let's say string Rahim. So this we are repeating Rahim now. So now these are strings we have right here. Yeah, strings. We are storing them. We're using these quotation marks. You can actually use this smaller one here with actually one. You can also use these major quotation marks. Everything works fine in that when you use that one. So now when I talk about a string, let me actually use the strings to print out the statement. So I would say go ahead and say print. So now what I want to do is I want to tell the compiler add these two strings and give me a fine output. Yeah? So I want the compiler to get my salutation, bind it with the name, and give me an output. So what I'll be doing here is what we call string concatenation. Yeah, string concatenation. What string concatenation basically is you combine two strings. You can actually combine the first string and the second string. So you can say salutations just by typing the word salutations plus plus that name there, plus the name. Let me end it there. So now what salutations and the name. So when the compiler is printing out, it will give me out. Let's print that out and see. So let me go ahead and print that out. I'll basically say print salutations plus the name of the person you're greeting. Now let me save and run this. Save, run this again. We'll say hello Rahim. But when you look at exactly what we printed, there is no space in between. This is because when you look at the strings we've given the compiler, we didn't space anywhere. So when you actually want to make it, I would say, more readable, you can actually come here on Rahim, let's add the space bar, let's add the space there, and we run it again. Now it's printing hello, hello Rahim. Yeah, it's giving me response, hello, hello Rahim. Now basically the strings. So actually with strings, you can actually use these strings, you can actually customize them in many different ways according to what suits your demand. So let me actually customize one of these strings here. I'm remaining with only the name. Let me remain with the name right here. Let me delete everything else. So this is our string now. We have the string named Rahim, string Rahim. So you don't have to worry about that. That's a variable. So that can basically be used to store everything. You can store integers there, you can store doubles there, you can store names there using the var keyword. So these are what we call keywords. So now let me say var properties of strings. So equals, now the string actually has different attributes that go with it. So name dot. So you can actually see the list that pops up here. We actually have very many functions, a lot of what you can choose from. So let's say we have this name right here, and I want to make this name a capital A, to capitalize the whole name. So I would say name dot to uppercase, open and close. So let me print it out, and you see print, then properties, save and rerun your code. I think now you can see our name is in capital letters now. Rahim, it's in capital letters here. Over here on the terminal, it's in capital letters. So now if imagine that we had this very name and we wanted to make it to make it a small letters. So imagine we had a name in capital letters, Rahim. So now what I want to do is I want to get this string over here. For example, the user has given us a name. We're collecting data from a user, and the user gives us a name that is in small letters, and we want the name to be stored in capital letters in our database. Now what you have to do is to get the string, pass it over, and make it a capital, and make it small letters. So I use this dot operator, dot to lowercase, then open and close brackets. Of course, we don't forget our semicolon, because if you forget a semicolon, your code won't run. So when you save and rerun again, I think you can see now our name is in small letters. So that's one of the properties of a string. So let me actually show you one thing here. So when you forget this semicolon here, your code won't run. That is going to actually throw you an error. I think you can see error expected a semicolon after this statement. Like it actually highlights out where it expected a semicolon. So the semicolon is very important, because if you use a compiler, you should be stopping here. You understand? Now let's actually move on to the next property of a string. You can see the name. Let's use the dot operator. Dot. So the other property we can actually talk about with a string contains. Now what actually this does is, actually when I hover through, you'll be seeing what it does where the string contains a match of letters. So let's say we have our name here. We've gotten it from the user, and we want to check whether this name contains. We want to check whether this name contains, for example, a given letter we are looking for. I can actually want to check whether the name contains the letter A. So we just have to type in the letter A, save and run our code. It returns a true statement. What it means here is the letter you're looking for is actually in the word. So that's basically what it means. Now when I pass in a letter that is not in the name there, for example, I'm passing in a U, it will return a false statement. It gives me a false. So what this false means is this name does not contain the letter U. Yeah, dot contains, that's what it does. So let's move on to the next property, which is dot index of. So now look at this. When you're actually looking at this closely, you can actually see this index begins with a small I, and the O is a capital O. Why? This is what you call common notation when you're coding. It's what you call common notation. For example, I can say this is in common notation. So I think you can see every time you're beginning out, you begin with a small letter, the next word begins with a capital letter, and so on and so on. That's what you call the common notation coding. So now, actually what you call indexes, because when the computer is storing these and reading them on the memory, it gives them indexes. So now, I think it's a concept you have to be familiar with. So with indexes, when it's giving them indexes, it begins with an index of 0. For example, this letter R will have an index of 0, the A will have an index of 1, the H will have an index of 2, the I will have an index of 3, and the M will have an index of 4. So these are our indexes now. They all begin with 0. Everything begins from 0. For this computer, when they're storing information, the first index is 0. So when I check for the index, for example, name.index of, and I pass in the letter R. I'm passing in the letter R to see what index it has. Let me first clear the terminal. When I run my program again, it will return a 0. So what this 0 means is the letter R is stored at position 0. Now let me check, for example, for the letter H. When I check for H, it returns a 2. Why? Because it's stored at the position 2. Yeah, that's what basically this property does. An index of, it checks where the letter is located in the string. So the other property we can talk about the property of the length dot length to check how long our string is, how long it is. So when I save this program and run again, it returns a 5. So when actually to count the letters in the name Rahim, we actually 5 letters. Yeah, that's true. So what it does, this index, when it's returning the length, it adds a 1 to the last index. For example, the last index here was 4, so plus 1, it returns a 5. Yeah, that's what we do with strings. So now let's move on to the next data type, which are integers. The next data type, we talk about integers now. So these integers, I would say int, which is actually, this is a keyword, int, int. Int, I would say numbers. So I can actually say numbers equals. So I pass in any number, any desired number. I can say, let me pass in a 17. Just like that. So after passing in this 17 now, we move on. Let me say I want to print it out. Print numbers. When I run again, it prints the 17. So now if one would be wondering why is that when I'm storing numbers I use an int, and when I'm storing strings I use a string keyword. So this is very important actually. Why? It's important because when the compiler is running through code at runtime, it's reading through this code, it knows that this is an integer and this is a string. So there are some things you can't do to a string that can be done to an integer. For example, you can't add strings, but at the same time you can add up integers, or you can multiply integers. So that's why it's very important. So let me give you a short example. When I use the keyword string, let me say, for example, string name, and I pass in any name of choice. I can say, for example, let me pass in the name Peter. When I save, for example, now what I want to see is what does the compiler know about this? What does the compiler interpret from this string? I have to say print. Then I give it the name dot. Now to know what it defines it at the runtime, dot runtime type. The same thing with our numbers, dot runtime type. And I save and run again. Now you have to see. Now with this name, print name.runtime type, it returns a string, meaning the compiler knows this is a string. So moving on to the next one, it returns an int, meaning it's an integer. Yeah, that's basically the most important thing here. So now let's go through some of the properties of these numbers, of these integers basically. So now we'll talk about integers. You can't store a decimal place in an integer. That's actually, those are stored under doubles. So now with integers, what I have to do is, let me show you a few properties of the integers. I'll have to say, for example, properties will be equal to numbers dot. I can actually tell whether this number is an odd number or an even number. For example, I can say dot is even, just like that. Then print out this property and see what it returns. Print out property. So when I save and run my code again, it returns false. Why is it returning false? It's returning false because 17 is not an even number. I think you can see that. Let me say is odd. To see if our number is an odd number, is odd. When I save and run again, it should be returning true because our 17 is an odd number. Moving on to the next property, you can say, now imagine at this very point, one thing we want to check for is we want to convert this number to a double to give it a decimal place. Now what you have to do is to say numbers dot. That can be done in two ways actually. You can do that in two ways, but one of doing that, you can say flow. Let's call the flow function, save and run again. Sorry, I need to use the flow function. We'd say numbers dot double to double, just like that. Save and we run again. It returns a 17.0. Wow, why is it returning a 17.0? Because I've converted this integer here to a double or a floating point value. Let me clean my terminal. Those are actually a few properties of the integers. Now, let's say now what we want to do is let's look at the doubles. You can actually say double, but just by using the double keyword, you can say double decimal is equal to, and that's something very close. I can say double rem anything of choice is equal to, for example, 12. It's like that. Now look at when I say print this rem, I'm printing out the very number that I just typed in. And when I run my program again, you will see it prints out 12.0. Why so? Because I told the compiler this is a double, so all it interprets is 12 point anything after the decimal place. So I don't have a decimal place now. It converts it to a decimal, which is 12.0. Now imagine at this point, so for example, you have a given number, for example, the value of pi, any given any decimal place of choice, for example, 34 point something very long. So what you want to do here is you want to convert this, I would say, this long decimal place to a small one. So what you have to do is we say rem dot round. So now it's like a rounding off. So it will do. Let's print out now what we have. Print rem dot round. When you run your code again, you have a 35. Because when you round off 34.6, you get a 35, you understand? So it converts it to one integer by rounding it off. So when I give it a value, for example, when I give it a value that is smaller than 5, and we run again, it will say 34, because when you round off 34.3, you get 34. Now, another property that we have with this one, what you can do is you can convert them to strings actually. That we call type conversion. But let's look at the next data type, which is a bool. So I think this looks a little weird, which is a bool. So what actually these bools do, they store two values. They either store a true or a false. It's either true or it's false. It can't be anything else. It can't be in the middle. It can't be an intermediate. So you can say bool, for example, truth equals true, just like that. So when I print out this boolean here, when I print out truth, what you'll be seeing here is it returns a true because this statement is true. And actually use it to store like a false. When I run it again, it returns a false statement. Yeah. So now let's look at the comments just to make it brief. So you can actually write code. If I can actually show you some of my recent. Let me see. What example can I get you? Let's put that aside. So let me open up one of my recent projects and you see. So when I open up this project here, you'll be seeing we have many lines of code. So when you get to bigger scales, for example, you have this many lines of code and you make a mistake somewhere. So when you make that mistake somewhere, you can't say you can't easily find the mistake where the mistake is. So what you have to do, you comment out some lines of code. Or for example, you want to say, now this line of code does this and this. If someone is reading through your code, they will be able to know that. So what they have to do. Now when I'm writing a single line comment, let's go back. So for example, if I want to write a comment that is on one line, I just have to use this forward slash. Just two of them, two forward slashes, and you say, for example, single line comment. So now you're asking yourself, what's special about these comments? Now, these comments, when you run your code or when you compile your code, the compiler just skips through these comments. It doesn't compile the comments. It doesn't read through the comments, so that it doesn't do anything about the comments. When I compile again and run, you see the very output we had. So it has nothing to do with the comments. So imagine I'm writing comments that are not on one line. So for example, that was a single line comment. If I type something below here, it would be a comment. So when I'm writing something on more than one line, it has to be a comment. I just type in the forward slash and this asterisk. So it comments out everything below that. Yeah? I can say, for example, this is a multi-line comment. So where you want the comment to end, you just have to type the asterisk and the forward slash still, so that our comments end here. This is a multi-line comment. So there's actually something else you call a documentation. So what you use here is you use 3 forward slashes, 1, 2, 3 forward slashes. You can say this is a documentation. These comments are very important. So these comments, they help you actually. For example, you have a very large code base like the one I just showed you, a very large code base, and you have an error somewhere, but you can't delete your code because, for example, when you delete, you can do what is important. So you just have to comment out the code that you suspicious of and run the program again. And at the same time, these comments help you to know what to. For example, you write your code and you take multiple days without looking through the code. It's very easy to forget what you wrote. So you use the comments to tell yourself what the code does. I actually have comments somewhere that I can show you. Yeah, for example, this is a comment here, single line comment, loop to verify level of education. So I think you can see that. Now this comment reminds me that this is what this does. In case I've taken it without looking through the code, so it's easy for me to interpret what this does. Yeah, but you don't have to be scared about this large code, because at the end of the day, it's the basics that we. So now we're done with the Boolean data type. So I think now one big thing we should be looking at is conversion, string conversion. Now imagine at this juncture, for example, you might have, for example, a string. I might have something, for example, like an integer. I might have an integer which is called age. Of course, you can't have age that is 17 point something or 19 point something. That's what age. Age is not in decimals. Age, of course, has to be an integer. 17. So, for example, now you want to pass this 17 as a string, to convert it to a string. Now what I have to do is I say age, something very simple. Let's throw it in a given variable. For example, I can say string age. You can actually use any name of your choice, string age, and say. Now I'm converting it to a string. I can say age dot to string just like that. Now when I print out, for example, I'll be printing out two of them. I want to print out the exact age. I'm printing out the age. Then I'm also printing out this one that is converted. We print out string age. Now when I save and run my code again, clear here. I save and run my code again, you'll see it prints out 17 and 17. So of course you can't easily see the difference between the two, but there's a difference between the two. So at runtime, the compiler will know that this age is an integer, but the one that I just converted here, this age dot to string, it's a string. It interprets as a string basically. Dot. Now let's see what the compiler thinks of this. Dot runtime type. Same thing here. Dot runtime type. So when I save again and run my code, think you can see. Now for the very first one here, that we printed out, print age.runtime type returns an integer, meaning that our compiler interprets it as an integer. For the second one, it's a string. I think you see now how important that is. It's important in very many aspects. So now we can move on. For example, I might have my double. I have a very large number. For example, I can say 177 point some big number there. I think you see now it's highlighting this decimal place. Why this is an integer? It can't do a double. So when I hover over here, you'll be seeing a value of type double can't be assigned to a variable of type integer. So meaning you can't store a double inside an integer. It simply denies it. Of course, when I compile and run again, it will be throwing me an error if I thought I was printing that out. Let me save and run that and compile that, and you see it returns an error. I think you see that it returns an error, so you can't store a double inside an integer. Now when I move on to the next thing, for example, let me make this a double. Suppose it will no longer be age can't be decimals. For example, let me say value x. This is some random value. So now what I want to do, I want to convert this to an integer. What do I do here? Something very simple. So you just have to come and say, for example, I can say value integer type. If you want to make that an integer there. So what you just have to say is, come here and say int dot pass open parenthesis. So you pass in the value now. Let's say we pass in value x. Let's see now what problem we have. Can be assigned to the parameter type string. Okay. It's very okay. Now I want to convert this to an integer. I want to convert this. I want to convert my value x to an integer. I just have to say value x dot int to integer, just like that, to integer. Then close that. Then let me print that out, and you see print integer type. So when I compile this code and run, I think it returns me a 177, meaning it has converted. What it does, it basically cuts off these decimal places, cuts off those. Now imagine this very large decimal place. You want to make it, I would say, to make it shorter. So what I can do, I can make it, I would say, I can give it smaller decimal places. For example, how many decimal places do we have here? We have 1, 2, 3, 4, 5. That number of decimal places. So if I want to make them smaller, I can say dot to string as fixed. To string as fixed. Commutation, of course, is fixed. Now within these brackets, I pass in the number of decimal places I want. For example, I may want 3 decimal places. I pass in 3 and run the code again. Now it gives me 3 decimal places. It even rounds off the numbers for me. You can see how convenient that is. Yeah, that's basically what happens. Now, anyway, thank you guys for being around today. So in our next tutorial, what I want us to do, I want us to write programs that can take input from the user. Where you can say the user types in information and you use the information, for example, to give them a message or anything else.